So here we are, lesson 3. So this is what we should be doing the week of, I think, April 3rd. If you're doing it the week of March 30th, that's not a problem. Just know that you're a little ahead. So we're going to do 3 things. Identify sides of triangles when I'm given an angle, decide which trig ratio to use, and then actually find angle measurements. One of the things I noticed when I was grading your first set of lessons and free responses is that some of us are really not good at figuring out opposite and adjacent. We just want it to be the same every time. So what I've done is I've given us 4 triangles that we can use, and we're going to do sine, cosine, and tangent for each of them. So the first thing you're going to do is you're going to find the angle that you are coming from. So here's alpha. And then you're going to draw a straight line all the way across. That's your opposite side. Then you're going to find the side that's closest, kind of make a little loopy like that. So this then is adjacent. And then we have the hypotenuse. Remember, so, ka, toa. Make sure you have that written down somewhere you can reference it. Sine is opposite over hypotenuse. So the sine of alpha would be x over z. I can use variables. I don't have to use numbers every time. Cosine of alpha is y over z. Very good. And the tangent of alpha, opposite over adjacent, x over y. Go ahead and pause the video, do the second example over here, and then turn the video back on and check your answers. So sine should have been b over a, because if I draw a straight arrow, I hit side b. Cosine then is c over a, and tangent is b over c. If you got one of those wrong, go back and fix it. Once we get to this third and fourth one, I'm really mixing it up. The triangles are oriented in very unusual directions, and I'm using symbols instead of letters or numbers. So the first thing I want you to do is label your opposite, your adjacent, and your hypotenuse. Pause the video and do that, please. Opposite is the smiley face. I bet half of you said adjacent is the square. Nope, adjacent is the heart. The square is the hypotenuse because it's the longest side. You can also know it's the hypotenuse because it's across from the right angle. See my right angle? They're across from each other. Go ahead and pause the video and write your sine, cosine, and tangent ratios. Sine is smiley face over square. There we go. Cosine is heart over square. And tangent is smiley face over heart. Last one. Go ahead and do the whole thing yourself. Pause the video. Write out your sine, cosine, and tangents, and then turn the video back on. So the sine of m is arrow over star. I bet you that was kind of confusing, wasn't it? Well, what's furthest away from, that's mu, by the way. It's a mixture of m and u, mu. Cosine then is triangle over star, and tangent is arrow over triangle. Miss Meyer, how come you're making us do this with weird symbols? Because it makes your brain really think about the pieces and parts that you have. Our second objective is that we need to know which trig ratio to use to find our measure. So let's look at this first example. So I've got theta. What do I have given sides A and B? Well, first thing we're going to do is we're going to find the opposite side. So this is opposite. What's B called? Correct. B is called the hypotenuse. So if I have opposite and hypotenuse, and I go back to SOH, CAH, TOA, which one of those is opposite and hypotenuse? The sine of theta is A over B. Cool. Let's go to our next one. That's a weird looking alpha, kind of squished. Go ahead and label your sides, opposite, adjacent, and hypotenuse, and tell me if it's sine, cosine, or tangent. Pause the video and go for it. You should have said cosine. The cosine of alpha is equal to the adjacent side over the hypotenuse. So r is definitely the hypotenuse, and x is adjacent, so we should have had x over r. If you got it wrong, you need to put a little star here and say, I got it wrong, here's how I need to fix it. Don't just keep going through the notes and getting things wrong. Look at this last one. Is it sine, cosine, or tangent? We have tangent. I'm glad that I didn't have to tell you to pause the video that time. That was really cool. So there's opposite. Here's adjacent. This side down here is the hypotenuse. Since there's nothing on the hypotenuse, it has to be tangent. Smiley face over heart. Cool. Now it's calculator time. Let's look at our first example here. Well, yeah, let's look at our first example here. Sine, cosine, or tangent. Sine theta is equal to 4 over 12. Now you need to crack out our good old universal calculator. Remember, if you're going to use your own calculator, you have to figure out what buttons to push. Oops. There we go. So let's see, sine theta. So in order to find theta, I'm going to do inverse sine 4 over 12. In your calculator, it's called sine, it's called A sine. So I clicked the 3 buttons in the top left. A sine. A stands for angle. So I'm going to put an A right here to help you remember. So we're going to type in A sine 4 divided by 12. What's the measure of my angle? 19.471 degrees. So theta is 19.471. Don't forget the degree mark. The degree mark is super important. Let's look at our second example. Sine, cosine, or tangent. Pause the video and set it up. Correct, we have tangent theta. And that's going to be 4 over 12. So theta will be A tan, go Meyer, 4 over 12. A tan 4 divided by 12. Well, theta is 18.435 degrees. Ms. Meyer, how come it's not exactly the same? Because I have 2 different triangles. I have one triangle where the hypotenuse has a length of 12 and another triangle where the base is a length of 12. Let's try this third one. Is this sine, cosine, or tangent? Look at where theta is. Be careful. Look at where theta is. Is this sine, cosine, or tangent? Pause the video. Very good. This is cosine. 4 over 12. So I'm going to say that theta is equal to A cosine, or the angle given cosine, 4 over 12. A cosine 4 divided by 12. And this time, theta is 70.52 9 degrees. There you go. Now, I did put a word problem in here, but really the word problems are for the next video. So instead, I'm going to give you a couple triangles that you need to do on your own and turn them in with your notes for today. So no, you don't have to do the water slide problem unless you're feeling spicy. Go ahead and pause the video or just do the homework as I'm doing it. Let's use mu again. Mu is something we use in statistics. Let's do 7 and 13. Let's draw a different triangle. Let's call this one alpha, because alpha's fun. And let's call this 3 and 4. So let's see. I've done that. I've done that. I wonder what the third kind of triangle I need to do is, so that you do all 3 trigonometric functions. I've done that. I've done that. Let's use theta this time. We don't like coming from the top left, so that's where we're going to come from. Let's see, what are we going to do? Let's do 11 and let's do 12. Remember, you have to do these problems before you turn in your video. Good job, my friends, and I will be in touch.